Okay, that will get things done more efficiently.
Yes, sir. Yeah. So I have a few doubts.
Please.
Sir, we were given in our notes that
Or other parts are okay. You understood SN1, SN2 properly, is what you said.
I think I feel like I understood.
Your teacher has clearly covered the various factors which influence the reaction.
Yeah, like comparison between SN1 to E1, SN1, like
All sorts of comparisons have been clearly covered, so to say,
yes, sir.
including, I'm assuming, what to say,
SNI.
all factors. Basically, the carbon group factor, the leaving
Mm,
group factor,
yeah,
the solvent factor,
solvent, yes.
uh,
Temperature.
nucleophilicity and basicity aspect over there of
Yeah,
the attacking substrate, attacking fellow.
he didn't talk about much about nucleophilicity because we did in alkanes, but then yeah,
But basically,
yeah,
every one of those factors have been covered already,
yes, sir. Yeah.
clearly covered, and you are properly clear with each
So
other.
nucleophilicity, I have like in many questions I've seen like they're asked to compare the nucleophilicity. Like, are we supposed to remember that, or like can we do it with logic or something?
We
Because
can logic. Why should you have to
I
remember?
wasn't able to like.
Ask the ones where you seem to have an issue where it doesn't seem logical. Then we'll talk. That'll be easiest.
I mean,
I mean, that's where it'll be going now. So tell me which ones you found illogical, so to say.
not that it's like illogical, but like uh,
Rather, something where you felt you had to remember. Tell me where all you had to remember.
sir, for phenol and this, what do you call this? Methanoic acid, ethanoic acid. Sorry.
Phenol and ethanoic acid.
Yes, sir. Sir, I thought maybe because ethanoic acid is a like,
Ethanoic acid, acetate ion, phenoxide ion and acetate ion.
yeah, that, yeah,
So phenoxide ion and acetate ion
yes, sir.
comparison.
Yeah.
Okay, all right. And yeah, I should have. What do you have as an issue there?
I mean,
Which one was given as more nucleophilic or more basic?
sir, CH3 one is given. Acetate.
Sorry,
Acetate ion is given, sir.
has been given as what?
The better nucleophile.
Okay, and which has been given as more basic?
Uh, so I guess it's that one only. 1 second. Sir, it was not in notes. Like, it was in a question.
Okay, phenoxide ion and acetate ion.
Yes, sir.
Okay,
Just 1 second. Okay.
so among these two, if we are looking at, let's call each of these one and two. You're able to see my screen, I suppose.
Yes, sir, I can see.
If I'm calling these guys one and two, give me the basic character first.
Yes. One will be greater than two.
Good. Why is one greater than two?
Sir, because that pi bonds are no, sir. We were given one reason. Like it was. I don't think it's for this one. 1 second.
Why basic character wise one is greater than two? Answer is correct.
Yeah,
Why?
sir. Because it the conjugate acid will be a that will be a strong. Wait, 1 second.
You went in the
Strong.
right direction. Basically,
Yes,
you have
sir.
to compare what you have to compare
The acids of the. Yeah,
and
exactly.
acetic acid.
Yeah, that's why I asked. Yeah.
Among these two, which is a stronger acid? The fellow who's called an acid is a stronger acid.
Yes. Yeah. OH.
It's
CH3OH.
definitely going to be a stronger acid.
Yeah, COH. Yes.
Definitely, that means the complementary fellow is going to be a better base.
Better base. Yes.
So, yes, you're going to be having phenoxide ion definitely being a better base compared to the acetate ion.
Yeah.
When it comes to nucleophilic character, though, it is not about the basic character which matters. It is about which end is going to be attacking. In this here, with respect to nucleophilic character, What is the idea here? What was the nucleophilic order which you got?
Said in the answer,
Mhm.
said it was between four different stuff, but then between these two, we got CHCO minus is greater than PHO minus.
Okay, as a nucleophile.
Nucleophile, yes, sir.
So you think and tell me what could be the problem there? What does nucleophile mean? Do you remember the example or the visualization which we used over there?
Yes, sir, yeah.
What
Beggar,
was the visualization?
beggar.
Bigger. So bigger, where or what can be more easily approachable for the beggar? In the acetate ion, both of these locations are equally susceptible.
Hmm.
Because you're going to be having perfect resonance, right?
Yeah,
So
between the
because
seeds.
you have very good resonance over there, both of these locations are going to be equally good. In this case here, you have learned electrophilic aromatic substitution,
Yeah,
correct?
yeah.
So now tell me in the phenoxide ion, which fellow is the actual nucleophile? The less electronegative fellow will generally be the more donating one,
Yeah, exactly.
right? In this entire system here, the O minus is the more electronegative guy. Which guy
Yeah,
is less electronegative fellow?
the pi bonds of carbon.
Pink. So what happens here is this resonance happens, which
Downward from
makes
the. Oh,
each
I
of
see.
these spots better nucleophiles.
Hmm.
That is the main reason why this guy becomes slightly better compared to this, if that excuse is given. But that is not going to be the case in all systems.
Sir, but then, um, 1 second. Here are we comparing the strength of each of the sites or like number of sites? Because both of them would matter, right?
Think of what nucleophilicity means. It is
Approachability.
about comparing the strength of the best set.
Yeah.
Okay. In this here ring over here, you're having multiple locations, which is definitely going to be decreasing the probability. And more critically, each of these, if it's going to be attacking from the ring, that's a fat location. There will be more repulsions. In this case here, when you are having resonance happening here, both of these become equal,
Hmm.
which means the probability factor of having two locations actually gets cancelled out over here. Whichever location attacks, the other fellow will compensate and become the double bond.
Yeah, almost symmetric. Yeah.
So this acetate ion here has major advantages when it comes to the nucleophilic character there, because you're going to be having the two locations becoming equal.
Armated nucleophile.
And when you're going to be having the phenoxide ion is also something which is ambident technically.
Yeah.
It is going to be something where the carbon ending, the ring is the one which is actually going to be, what to say, the better donator.
Hmm.
And while phenoxide ion performs very good, what to say, electrophilic aromatic reactions.
Okay. Hmm.
See, ultimately, I will be very blunt and honest with you here. Organic chemistry is going to be chock full of these kind of, what to say, half-baked logics.
Hmm.
In a sense, I am not even sure whether the answer you gave is correct or not. But if that answer is the case, this will be the logic associated with it. So the problem here is most of this is hindsight. You understand what I mean by hindsight, I
Yes,
suppose.
sir. From the answer getting.
Bulk of the time, it's actually about what you literally said, which is knowing the information and then targeting. I am still not completely convinced whether acetate ion is a better nucleophile, because my brain tells me phenoxide ion and the carbon ending is a far superior nucleophile.
Oh.
Provided the rings, what to say, problems with respect to bulkiness are going to be not taken into account. Because generally, when it comes to nucleophilic character, it is about the fact that that ending is not going to be surrounded by too many water molecules. That ending can comfortably go attack. All of those will matter.
Hmm.
From those points of view, phenoxide ion wala carbon ending, the para location seems quite primed actually. But if you consider the phenoxide ion oxygen ending, that is a problem. That is definitely going to be a weaker nucleophile compared to the acetate ion. But if you do consider the carbon ending, that probably will be better. So I am not particularly sold on the logic which you, on the answer which you just gave. But if that answer is correct, this will probably be the logic associated with it. Now, what other issues? You said you have some doubts. Let's start
Yes,
off
sir.
with your doubts.
One second.
Give me a second. Let me just go pick up some water.
Yes, sir.
Yeah.
Yes, sir. Yeah. Sir, we were given that alpha haloaldehydes and alpha haloketones are reactive for SN2 reaction, and he gave a reason of like
Mhm.
lowest unoccupied molecular orbitals in
Mhm. Mhm. Repeat. Alpha halo.
alpha haloaldehydes and alpha haloketones are highly reactive for SN2 reaction.
Hmm. Okay. So this is the species which is given, and they're telling you that this location is very primed for SN2.
Yes, sir.
Okay, that is correct. What was the problem which you have there?
Sir,
Why is that the case?
sir, what?
No, I mean, you have an issue with why that is the reality, is it?
Yeah, they were saying some about like each has like a lowest energy empty orbital, so they combine to give. I did not understand, like, to give lowest unoccupied molecular orbital which has lower energy than the pi star and the sigma star. So we are.
Okay, stop. We both know the moment somebody goes there, that basically means they are bullshitting. So stop that and think your own self. That logic is like किसी बुक में लिखा हुआ है, रटा के यहाँ पे मार दिया है, छापा है, वो छोड़ो, तू खुद का सोचो. You are somebody who likes to think. What does it mean when you're going to be having SN2 happening here? SN2 means you need to attack that location.
Yeah, 1 second.
So first, let's move into what is this being compared with? What is this with respect to? When you're saying this is going to be doing good SN2, what do you mean by it does good SN2? Without comparing it with something else, there is no meaning in saying this does good SN2. What are we comparing it with?
Normal carbonyl groups.
Normal alkyl halides. Normal
Oh,
carbon compounds don't do goddamn SN2.
not like beta don't do. Wait.
Beta, okay, let's go with the beta. So this would be a beta.
Yeah.
Okay. So I'm going to be having this is the alpha, this is the beta. Okay. Now SN2, what is going to be happening there? Some fellow has to basically come and attack.
Yes, sir.
So listen to me, what are the general factors which matter?
The steric hindrance,
Good. So
leaving abilities.
let's put it as steric hindrance itself. Steric hindrance at site of attack. Okay. What else?
Sir, electron density at the Side to
Okay, let's put it as a delta plus on
yeah.
location. Okay, then attacker, leaving
Lead.
group,
Yeah.
solvent,
Yes. Fair
and
answer.
of course temperature.
Hmm. Yeah.
Temperature decides the competition between the
E1 and SN2 and E2.
So now these are the more or less acceptable factors. Now, if you're going to be looking at these factors over here, attacker is going to be something inconsequential when you compare because both will be assumed to be the same.
Hmm.
Leaving group, we'll take it as similar, of course. Solvent, we'll of course make sure that is also taken care of as similar. Temperature will also be taken care of as similar. So among them, which ones are going to be the only factors which are really going to be playing a role? Steric hindrance and delta plus.
Yes, sir.
Now, let's look at the delta plus factor first. That is the easier factor to look at. From a delta plus factor, if you're comparing the alpha halo, beta halo, and a normal halo, forget the keto thingy existing. If you're having a normal alkyl halide type of system, the delta plus on this fellow here, let's call it as delta plus 1, let's put this guy as delta plus 2. Definitely delta plus 1 is going to be higher compared to delta plus 2.
Yes.
So from this factor point of view, it's perfectly acceptable.
Yeah.
Screw all of that, what to say, molecular orbital mumbo jumbo, which was bullshit over there. Now, from a delta plus factor, it is commonsensical now.
Yeah.
From a steric hindrance factor, how would you look at it? Do you think this causes steric hindrance?
No. Wait.
Why?
Because the nucleophile
Saying
is.
why? If you're saying yes, why?
1 second. It'll attack from the opposite side of 1 second.
My question was very specific. Is this going to be causing steric hindrance? The carbonyl group. When you want to check for steric hindrance, how do you check?
Hmm.
You check whether that is going to be sp3 first,
Yeah.
because sp3 means it occupies more space.
Yes.
If the arrows are sp2, they are
Yeah.
flat on a plane. They don't occupy much space,
Hmm. Okay. Okay.
right?
Yeah. Yes.
That means there
Correct.
is room above and below to a good extent.
Hmm.
So
Yeah.
the
Yeah.
carbonyl group does not offer much steric hindrance.
Hmm. Okay.
The carbonyl group offers what though? Is it
Repulsion.
going to be offering any competition for the nucleophile?
Yeah. Because O minus also O will also have nucleophile.
Not like that. I do not mean that.
Oh.
See, this location and this location, these two locations, are they in competition with each other? Because this
Like,
location here also has a high delta plus, correct?
sir, but then there you can. There's no leaving group to leave. No.
See, that's what I'm trying to tell you here. In this case here, in the alpha halo there, the main thing which might happen is that you might have nucleophilic addition happening on the carbon.
Hmm.
Why? Because this location also has the same
Also the
delta.
delta plus. O is pulling the
It
delta.
has a higher delta plus,
Yeah. Maybe. Yeah.
right? So if nucleophilic addition is going to be a possibility, that will possibly be competing more. But looking at nucleophilic, what to say, attack purely from an SN2 point of view. That is, if you make sure that the system, the solvent is going to be a nice polar aprotic type of solvent, which
Hmm.
will increase the nucleophile's tendency to attack as a nucleophile rather than go perform addition. Because in the addition reaction, what will happen? It will basically end up reacting as a base over that. It will be donating. And this fellow will be taking. The oxygen will take it up, correct?
Yeah.
So that is going to be a possible competition. So if you make sure that the nucleophilic addition becomes more difficult, automatically it should not be a problem. Now, one more factor which will basically come into the picture here is this. You learned about SNI is what you told me, correct?
Yes. That's what.
So when you're going to be having SNI, or let's call it neighboring group participation.
Hmm.
वो हो गया कि नहीं हुआ?
Yes, sir. Yeah.
So when you're going to be considering the NGP aspect over here, what happens is this. You can have this bugger going and attacking this fellow
Yeah.
and kicking this fellow out.
Yes.
And then an external nucleophile will come and attack either here or here.
Yes, sir. I had a doubt like in NGP regarding this.
Hmm.
Here when carbon bonds with the say, oxygen will get a plus charge, right?
Temporarily, but it has octet.
Correct. Yes, but then how come the nucleophile won't attack the plus charge there? Why would it go for the delta plus?
Think for a second what I just said. What was the point I said very specifically when you just pointed this out? I said
Octet.
oxygen has octet.
Hmm.
Think along those lines. The nucleophile will attack a site which is losing octet, which has a chance of losing octet, right?
Yes, sir. Yeah.
If the fellow is already having octet, and even when the attack is happening, that fellow will take the octet and only leave. You're basically asking why does it not attack the oxygen over there, correct?
Yeah. Yes.
That's what I'm trying to say here. Oxygen, even if it, what to say, leaves, it will leave with the octet. Who is the guy who gets screwed in the process when the oxygen leaves?
Carbon.
One of the two carbons.
Okay. Okay.
You understand where that goes now?
Yes, sir.
Okay. Next.
Hmm.
I'm assuming your doubt is cleaned here now in this part.
Yes, sir. Yeah.
Next question you have over here.
Sir, regarding this NGP, there's one question was I didn't.
I
Sir,
have a question here for you.
yes, sir.
NGP, what did you learn about neighboring group participation? Actually, you said you have questions on that now. Then I'll probe you there. Chalo,
Sir, it is a reaction.
huh. Hmm. What's your issue here?
Sir, I was getting a different answer. I thought, sir, first the lone pair of sulfur will go to the carbon, which is connected to Cl.
Let's first see what happens first. First, this bugger will attack here as a possibility.
Yeah.
All right, we get an S minus possible.
Hmm.
Then only we start off with what you are basically going with. Now, in this particular case here, yes, this guy can directly attack over here also.
Yeah, that's fine.
Now, let's start off with looking at the location of attack first. What type of a location is this? Is this good for SN2?
It's okay. I mean, not very good because
Not very good. That's the key point here first. It's not that good for SN2. Why is it not that good for SN2?
steric hindrance is at second degree
Steric
carbon.
hindrance is reasonably high.
Yeah.
Right? So steric hindrance is reasonably high. It is not going to be that efficiently good for SN2.
Hmm.
Okay. Now, what is going to be happening in this particular case here if the neighboring group participation does happen?
Lone pair sulfur will go to this.
Sulfur minus, and that bugger should come and attack.
Hmm.
If that bugger does come and attack, what is the ring size it forms?
It's a bicycle.
No, I did not ask that. I
No.
asked what is the ring size it forms. Forget about the bicyclochrome. When it comes to neighboring group participation, the key thing there is if I'm going to be having different fellows, oxygen, sulfur, halogen, if these guys are performing neighboring group participation, you need to see when that neighboring group participation is happening, what is the size of the ring which is going to be formed. For instance, if I'm going to be looking at oxygen, what is the ring size it prefers to form?
3.
No. 3 is possible. I'm not saying 3 is impossible. I'm not saying that. I'm saying what is the most preferred one? And
Mm,
avoid. Oxygen usually prefers to go for 5 or 6 or 3. Now, among the 5 or 6 or 3, 5 is most favored. All right. And oxygen will specifically avoid 4. Same goes for nitrogen, actually. The main reason being, when you're looking at a 4-membered ring being formed, the bond angle has to be closer to 90.
Yeah.
All right. And oxygen and nitrogen, when they are in sp3, they will prefer to go away from 90. Water and ammonia, their bond
Yeah.
angle is much higher than 90.
Yes. Yeah.
Whereas when it comes to sulfur here, this bugger likes to form 4 members. It has no problem with forming 4 member, because when you consider the H2S system, what's the bond angle for H2S?
Uh, is 90,
Closer to 90,
90
92, 93.
91.5, I think.
So somewhere near 90 is the bond angle for sulfur when it is forming the sp3 system.
Hmm.
What happens is sulfur can do 4-membered rings,
Yeah.
but sulfur simultaneously 4-membered becomes better. The other ones basically end up becoming slightly worse off. So in
Hmm.
this case here, if the sulfur is doing the attack, there are two things to consider. First thing to consider, can the sulfur attack from opposite direction in this case? Because this is a ringed system already.
Yeah.
Are they in a direction where you're going to be having the sulfur minus being in the opposite direction of the chlorine? That is one question to consider. Second question to consider, what is the ring size the sulfur is forming when it is performing their attack? And is that ring size a feasible ring size?
Hmm.
Two questions to consider here.
Yeah.
So in this case here, let's have a look here. This is going to be cyclohexane type system,
Yes, sir.
1,4.
Yeah.
So if this guy is going to be in chair form,
Hmm.
what will it be looking like? I think we discussed how to consider chair form, right?
Yes, sir. Axial and equatorial.
Long time back. I think I should have
Yes.
discussed how to flip the thing and run through that. I'm sure your
Yeah.
team in school also has done that, but
Yeah.
I remember vaguely discussing that with you.
Huh.
So this is a planar form here, correct?
Yes, sir.
So in this planar form here, you're being given clearly that the chlorine and the sulfur are on opposite locations.
Hmm.
But this is one, this is 1, 2, 3, 4. Right. So if I'm considering carbon 1 and carbon 4 in chat form, will they be in same conformation?
1 second.
So let's put this as Y. This will become inverted. This will become Y. This will become inverted.
Yeah.
Right. That effectively tells me that they are going to be in opposite conformations.
Yeah.
And if they are in opposite conformations, that basically means if I take this guy as axial and this guy is equatorial here,
HS will be. Yeah. Good. Hmm.
right? So this fellow will become the equatorial and this fellow will become the axial.
Axial.
So now let's look at the chat form now. So this is my chat form.
Yeah.
In this here, if I'm going to be placing these are the locations.
Yeah.
So now let's place the chlorine here. Where will the fellow be? Chlorine and sulfur will be equatorial, equatorial.
Equatorial. So side.
I have S minus here and I will have chlorine here.
Hmm.
Or I will have S minus above and chlorine in the bottom.
Yeah. Same.
So properly they are in opposite directions.
Yes, sir. Yeah.
So that is satisfied properly.
Yeah.
So now the next thing is only the ring size. So if this sulfur is going to be targeting this carbon, what will be the ring size it will be forming? New ring size. It will be 1, 2, 3, 4, 5 membered
Yes.
ring,
5.
which is not too shabby.
Hmm.
So this should happen. Did you assume it would not happen, or is it given it is not going to be happening?
No, no, no. I understood it happens. Yeah. Yes.
So then it is in sync with what is acceptable. Now, then what's the issue here?
Sir, at the end, like, I thought this OS minus would go and attack the carbon, but rather it was attacking the water and then the water left.
Sorry?
like when I was drawing what is happening, then it was like answer was given such that OH minus will attack the hydrogen of the S. Like they didn't said.
That's what I also went with, na. OH minus can attack here or here. So what did we first consider? Is this location good for attack?
Mm.
Good for SN2 directly. That was the first thing we talked about.
Yes, sir, yeah.
Is this good?
No.
No. Because it is not good, neighboring group participation will happen. And in this case, when the neighboring group participation does happen, we will have a possibility of attack on carbon 1 or carbon 4.
Hmm.
That is, if I'm going to be, say, tagging this carbon 4 here as an isotopic fellow, just to track kahan pe attack ho raha hai. Once I have the neighboring group participation happening,
Yeah.
what will happen? My sulfur would have already formed a ring like this as a bridge
Yeah.
type of fellow.
Yes, sir.
Then I can have either carbon 1 or carbon 4. Both of them are going to be capable of getting attacked now.
Mm.
Right?
Yeah.
Because now it doesn't make a difference. Both are equal now. The ring just has to break. Or this system, which is going to be a new, what to say, multi-ring, what to say, or bicycler type of system, will exist as it is.
That's what they say.
So there are two possibilities here. Either the product should be something where I have retention of configuration on this chlorine, and I put the OH on that same location as the chlorine with perfect retention. That is one possibility. If that is given, that is not a, what is a bad possibility. Or I can have on this carbon number 4 attack happening here.
Hmm.
Or I can have the ring, basically the bicyclofellow, just staying as it is.
Sir, without the OH minus attacking, wouldn't why can't the lone pair of sulfur just go to the
It cannot.
carbon?
It cannot. Mainly because the sulfur here is going to be a very poor donator. Think again. Sulfur
Okay.
has extra spaces, it has d orbitals.
Yes, it does.
So if it doesn't get a minus, why would it go and donate? It is already delocalizing its electron density in those places now.
Hmm. Sir, but then does this always happen? Like, should it always for the minus charge the internal nucleophile, or like in
See,
some other
let's
cases
let's
can?
let's let's, let's you're basically now coming to a fundamental question. When should you check for neighboring group participation? Correct?
Yeah.
That's
Well,
what this question is now coming to
I
us.
think yeah.
So now let me ask you a question here. You're about to start a small business. Okay. Who will you go ask for cash?
Parents,
Yes. Why?
because
Because
they'll give it. I mean,
no, it's not about they will give it. Banks will also freaking give it.
yeah, they can, but
Hmm.
yeah.
Procedure is more. More goddamn legwork has to be done.
Yeah.
So, what's the point which I'm trying to explain here? If neighboring group participation is even remotely possible, it should absolutely goddamn happen. And it will take priority over everything else. Why? Because that is that much easier. The probability of that happening is tremendously higher simply because the nucleophile is part of the same molecule.
Yes, sir. Yeah.
So if you're starting up something small, you will go to your parents.
Yeah.
If you're starting up something medium size, you will go to your parents and your relatives.
Yeah.
Only then you will start thinking about the bank and all of the other thing. Right?
Yeah.
So if a system, if a molecule has something which is, what to say, a site which is capable of getting targeted by a nucleophile, and if the molecule has a nucleophilic end which can act as a good nucleophile on some other part of the molecule, and
Hmm.
they can interact, that is where the ring size comes into play. That is why I basically was very specific about making sure that you are familiar with the ring size as possible. Because The ring size is extremely critical. This ring size is extremely critical. Then that is going to be very critical. I mentioned whenever you're going to be looking for neighboring group participation, only two factors to consider. Are they in opposite directions? Is the ring size acceptable? Only two things to watch for. So if they are in opposite directions, yes, it can happen. It's like, for instance, you currently will go and ask your parents because that is the easiest thing to do for you. Because you do not have access to other people.
Yeah.
In your circle who can give you access. You know what you will get from your parents will come with strings attached.
Yes. Yeah.
Absolutely.
Yeah.
But that is still an easier option right now.
Yes.
When you have more options with lesser strings attached, which will you prefer?
The resistance.
Exactly. Right. So it is all about whether the attack is feasible from a standpoint of whether they are in opposite directions and whether the ring size which is going to be formed is acceptable. When it comes to oxygen performing neighboring group participation or nitrogen performing neighboring group participation, they can do neighboring group participation even when they are not necessarily having a negative charge. Why? Because they don't have any
Good.
empty space.
Yes. Exactly.
So their electron density is not delocalized properly. So it's like cash sitting in a savings account being wasted. In the sulfur's case, the cash is there, but it is parked in stocks and bonds and shit.
Yeah.
It's nicely delocalized. So if the sulfur or something which has extra space suddenly gains extra liquidity of cash, then that fellow will go attack. Because that fellow is now looking to park that cash somewhere else.
Yes, sir. Yeah.
You're understanding the point over here?
Yes, sir.
So if the system which is in the molecule itself, which can act as a nucleophile, is something which is going to be not having enough delocalization of electron density, then that system can attack as a neutral species also. That's the case with oxygen and nitrogen.
Oxygen, nitrogen. Yeah.
Fluorine also does that. But if that system has delocalization, then
Negative charge.
you would prefer to have a negative charge.
Yes, sir.
Only then that fellow will become a better system to donate over. That is the case when it comes to sulfur and other systems which are having delocalized, which have extra spaces. But that doesn't mean the ring size should not be looked at. Ring size has to be looked at, and opposite direction has to be looked at. Those are definite factors. Other than them, this factor will come into play. Those two are the primary factors. You have to have the lone pair or the particular donator being in the opposite direction of the leaving group. That is first. If that is not satisfied, it will not happen. Second, ring size. Usually the ring size will take into the account the other factor also. The first factor will generally come into the ring size part over there. Okay, now what's your next part issue here? Now, the real question you should have asked over here is, how do you get the answer? How do you judge the answer in this kind of a question here? That is going to be the really tricky part here. If this question was given as a single option correct question, and what to say, the options given are not going to be having any of the funny answers, funny options I mentioned. When I mean funny options, if they have not given this chlorine here to be, what to say, or the nucleophile attacking on this carbon and retaining the location there. If they've given hydrogen, what to say, if they've given that the axial location is going to be taking the nucleophile there, you can happily say that is not going to be happening.
Okay.
But if the question option is single correct, and they have given you the ring formation over here as one product, and they have given you this chlorine getting replaced,
Hmm.
and they're giving you this chlorine getting replaced perfectly and retaining location over there. Or they have also given you this carbon as an isotopic carbon, and they have given this fellow also having a nucleophile possibility.
Hmm.
Then all of those are going to be tricky options. In that case, you have problems in deciding what to mark over there if it's single correct. Usually, if they give you this kind of fellow here and they are sensible enough to mark this as what to say isotopic there, it will be more than once a correct question.
Hmm. Yeah.
In which case, you will have to be very careful and mark all of those possibilities because all of them will work excepting what to say inversion at this location. At this carbon, if inversion is given, you avoid that like a plague
Hmm. Okay.
because that will mean direct SN2. Direct SN2 is the least favored.
Yeah. Hmm.
Now, what were the options given in the question here?
It said there was no options. Like,
There was,
there were no options.
there were no options. Then you can basically go for all of them. Logically speaking, you have to give all of them as possibilities. And in this particular case here, yes, the neighboring group participation will absolutely happen. It
Hmm.
satisfies the conditions for neighboring group participation to happen, so definitely have a chance of happening.
Hmm. Yes. Okay. Okay.
So is this puzzle cleared out?
Yes, sir. Yes. Got it now.
Okay, next one.
One
Neighboring
sec.
group participation level. Let's finish off the ring sizes here. Sulfur can
Four,
form
five.
four membered.
Yeah.
This is one of the few fellows which can form four membered, mainly because the bond angle which sulfur goes for is closer to 90. When the bond angle is closer to 90, it can bend properly and attack from the backside when it is forming a four-membered ring. Oxygen, nitrogen, and halogen cannot do that.
Hmm. Okay.
Halogen also can do neighboring group participation. Halogen will prefer three-membered rings. It can do five or six also, but it will prefer three-membered more. And if I'm going to be having, say, benzene ring, this guy can also perform neighboring group participation. It will
Yeah.
prefer three-membered rings. And if I'm going to be having, say, acetate ion type of system, this fellow will also prefer to form three-membered rings. That is like this.
Hmm.
So you'll end up having oxygen when it is in the form of partial sp2 type of system. It will prefer to form a three-membered ring. And halogen also goes for three-membered ring. And benzene type of ring system will also prefer to form three-membered rings when it's going to be attacking as a neighboring group there.
Yeah.
Okay. Now, any other ring sizes which I've forgotten? It's been a while since I've taught this shit, so I might have forgotten some of them. Any other ring sizes you have discussed in school?
No, sir, we heard about it.
Okay. And this is a nonsensical thing actually. This benzene ring crap. Why I gave this is because stupid little MS Chauhan questions will have this shit.
Yeah. It had.
There is that's the only reason why I'm giving this crap. It doesn't. It's nonsense. Yeah. Sometimes just gets frustrating when you see Indian authors purposely giving every possible nonsense. But chalo, he is now doing that. I saw the JEE mains papers, the questions which have shown up. They are not exactly tough, but they are asking nook and crannies more and more and more now. Organic method is easier only. Inorganic is getting very interesting. At least the parts of inorganic which are there in the syllabus are fairly interesting this time. They've definitely asked some good questions. How was the result in your campus?
So I think we got 199.98, I guess. Uh,
Yeah. Total में
no, the best in our campus is 99.98. I think he got like 275 or something. Something like that. 280 to 75 something like that.
that's a good score, huh?
Yeah. And
And
then CM batch one guy got 300. Yeah. I told you
yeah,
also.
yeah, one guy got 300, right?
Yeah. And two got 290 plus.
Not bad. That is the Madhapur batch. Yeah,
Madhapur. Yes, sir. Yeah.
not bad. But problem is the same equivalent campus in Narayana got four, and I think they had like around four 300s and maybe three or four or five 295 के आसपास. So Fiji has done well. Fiji has
Hmm.
done quite well. At least Hyderabad has done quite well. चैतन्य से तो ज्यादा किया है. चैतन्य तो वाट लगाता है इस बार. And surprisingly, they are supposed to have better students this time. I'm quite surprised with what has happened.
Yeah.
Chaitanya, from what I know, they are scrambling badly. No, I really mean they are scrambling badly. In a sense, one of my old friends is working in Chaitanya's main campus here.
Oh.
So the dude was telling me they are trying to buy students now. I was like, what the already सोच रहे हैं वो. I can understand that when the game is like really turned around, but there's one more round left over,
Yeah.
and very sobering reality. Huh. All right. Next question.
One second. Yes. Sir, when we're talking about leaving groups, like what makes a good leaving group? Like in one NGP question, I like I'll just tell you the question. So it's cyclohexane with at 1 and 2 there is C3S and Cl.
C3,
S.
CS3, yeah, C3.
CH3S, my bad. CH3S, my bad. Sorry.
Huh?
And then chlorine, which are anti to each other.
CS3,
No, CH3S.
CH3S.
Yeah, and chlorine are anti to each other on
Send
cyclohexane.
send the photo.
Okay.
My brain is not able to comprehend it properly. Sorry.
Yes, sir.
What the hell is CH3S? Is it CH3?
Yes,
S.
CH3.
Okay, it's a thio ether type shit. Okay.
Yeah.
What's the issue here?
So like I know that like chlorine would leave, but then why wouldn't CH bond break rather than Cl bond? Like I think I
Which bond break?
said when this thing attacks, one bond must be lost by the carbon, which is the C delta plus carbon, right?
So what you have basically got here is something like this. We have an SCH3 here, and we are having something like this. So the issue here is this bugger might come and attack here, and this might leave.
Yeah.
So what's your question now here? Let me mark them, number them here. 1, 2. Okay, and in this particular case here, what is the other substance which is put in?
OH minus.
OH minus. Okay, so if I am putting in OH minus, let's say the neighboring group participation does it. After it has happened, the sulfur will basically form a three-membered ring. But
Yeah.
this time the sulfur will be with a positive charge.
Yes.
Something has to break now.
Yeah.
So which is more susceptible for attack now?
for attack.
Hmm. To get attacked by the OH minus, something has to attack the system, no?
Oh, that's what you mean. Okay. Yeah.
So let's say we are having this. Somehow this has formed.
Yeah.
This guy has a positive charge now.
So
Where
what
will
about the
the minus
chlorine?
attack?
The chlorine?
Hmm?
The chlorine.
There is no chlorine. Chlorine's left. If neighboring group participation happens, chlorine left, correct?
Yeah, correct. But
Hmm.
okay, fine.
Where will the attack happen now then?
On the carbons,
Which carbon?
the attached to sulfur.
102 or CH3?
1, 2. Yes.
The attack has to be SN2 type.
SN2 type. Yes.
What will be the factors to consider?
Steric hindrance. Then
Which guy is my leaving group now? Sulfur is a leaving group.
yeah,
So which fellow will get attacked?
the methyl CH3.
Correct. So now, logically, if neighboring group participation should happen, methyl should get targeted here.
Okay.
What was the issue here? What was your question here? Let's
Yeah.
go back to the question.
So this. Yeah. Where would the this thing attack? Which man is like CH3 or like that?
That should attack the CH3. If the OH minus does attack this system, which is formed here, if the OH minus attacks this system, this molecule, or this system, if neighboring group participation has happened, if I have had this system formed, if OH minus attacks here, it will attack this guy. It will not go for these two. Simply because steric hindrance is much higher here. OH minus has to do SN2 type attack only. Why the hell would it prefer to attack the all of them are alpha to the sulfur plus?
Yeah.
Any one of them can basically be targeted then.
Exactly. Yeah.
Sulfur just needs to leave its positive charge.
Yes. Yeah.
So
So
where will
then,
it
what will be the product? Can you?
see? The product here is going to be something which will be the ring there with the three-membered ring. But the problem here will come is that three-membered ring acceptable? So
For
if
sure.
that three-membered ring was given as one of the options, I would pick that. If this is going to be some kind of general, what to say, question where you
No
have
options.
to go with whatever you want to go with, then you give all possible options. Organic chemistry, may if they are giving you something where it's a general question, you should not basically limit yourself saying ki yehi hoga. You go with everything which can happen. If they are giving you options, you pick the best.
Okay. Yeah. Mhm.
Option wala question hai ki kya hai?
No, sir. Just a general question.
General question, I will go with the three-membered formation there. I will also be giving the other possible attacks.
Yeah, attacking 1 and 2.
Hmm. Attacking 1, 2 will not be that great there. I actually go with OH minus directly going and attacking the fellow
Sulfur.
there. That is actually a more possible thing because yes, neighboring group participation can happen here, but sulfur will not prefer attacking, not that easily.
So initially, why is the OH minus attacking the sulfur? Because you said negative charge was formed, right?
Because there is no chance of forming a negative there, na? It is a thioether, right?
Yeah, correct. But then it could take the OH, CH3 away initially, right?
What?
Oh, my bad. Said nothing. I don't know. Wait.
This is a thioether system, right?
Yes, sir. Yeah.
Then there is no way this guy can get a negative.
What?
It can't get a negative. How can sulfur get a negative? It is attached to two carbons, Ra. And the sulfur is a shitty leaving group. It
Yeah,
doesn't
and CH3 can't
we
even
go to
leave.
the leaving group part there. When is it what is a good leaving group? A good leaving group is something which is going to be stabilized in the solvent when it is leave, once it has left. So in this particular case, the sulfur will simply not leave. The
Mhm.
chlorine minus is going to be a far better leaving group compared to the sulfur there. So OH minus will simply not attack one of the carbons attached to the sulfur in the first place. If that's what your issue was.
Okay. Okay, sir. Yeah. I got my answer.
What was the answer given? I am curious.
Sir, 1 and 2 was given, attacking 1 and 2.
After NGP?
Yes, sir, yeah.
No, I will not. That is not logical. That is
Okay.
just somebody playing bullshit there. If they've
Okay.
not even considered the possibility of the methyl getting targeted, yeah, that's what I would say.
Yeah, was not considered.
Next. Methyl is definitely going to be a much better possibility than 1 and 2, simply because of the fact that if it has to be attacked, you have to consider steric hindrance. And all three of them are alpha locations to my sulfur plus. So if
Hmm.
ring fellow is formed, yeah, if this guy is definitely formed, I would say the methyl location getting targeted is actually slightly higher probability than the other two.
Hmm. Okay.
Next.
Yes. I have a few.
So you have only doubts in random questions like this, or do you have doubts in theory as well?
No, I have doubts in like questions, like
Yeah,
in
all right.
film.
See, in questions, if you're going to be asking questions which are like open-ended like this, you're giving me a lot of room to escape, and you have to
Okay.
understand.
Yeah.
Give options that will make it more
Yeah. Now
what
I'm
is
sending options. Sir, yeah.
cut throat, so to say. That will give you better answers as well, because you are never going to be asked organic chemistry questions in a one-ended fashion.
Yeah.
Nobody will do that. If they're doing that, they are just pulling the wool over your eyes. That is not going to happen.
Hmm.
You're not preparing for goddamn Olympiads, for God's sake. You're preparing for JEE.
Yes. Yeah.
Now, question with what is the major product obtained in the following reaction? What's your issue here?
Sir, I if
This is a
the
very easy question.
sir what?
This is a very easy question.
Yeah, I know, sir, I know. But then why won't the OH attack? That's my doubt. Like why this why would the NH2 attack rather than the OH? Like that could NH3 could also act as a solvent, right?
Okay, okay, okay. Sometimes the questions you ask, dude, are unnecessarily stupid. Okay,
Like
now
I got the answer.
stop. Let's go for understanding basicity and nucleophilicity first again. Now, if I'm going to be considering basic character, nitrogen ending, oxygen ending, which is a better base?
Nitrogen.
Wonderful. So ammonia and water, or ammonia, ethanol. Ammonia is a superior base.
Yes.
Okay. So which should attack from basic character point of view?
NH3.
Good. Now, next, if I'm considering from nucleophilic character point of view, when is a substance a better nucleophile? When that
um
substance is more easily approachable, it's a better nucleophile.
yes, yeah, that's it.
So when you consider approachability, what does approachability mean? If I have, say, a system in a solvent, which is polar protic, like in this case, the polar protic fellow is going to be surrounding the location with the delta plus or delta minus with the opposite fellow there, correct?
Yes,
If I
sir.
consider water, what is the role of water? How does water make something a weaker nucleophile? Why do
Accumulates.
we prefer polar aprotic for SN2? You know that we prefer polar aprotic for SN2, correct? Why?
Yes, sir,
Why?
because if it was polar protic, then the water molecules would accumulate around the thing.
Accumulate around what? The
The
delta.
nucleophile. Yeah.
And which part of the water molecule will accumulate?
The hydrogen.
Correct.
Hydrogen bond will.
So the hydrogen being smaller will accumulate around the delta minus or the nucleophilic center, which will prevent the other fellow or this guy to go attack more comfortably. Right?
Yeah.
When will the accumulation be more?
When it's smaller.
Hmm?
Smaller.
Is smaller the matter, or is delta minus the more important factor?
Oh, delta minus.
Right?
Yes.
So that delta minus depends on what? How electronegative that location is.
Exactly. Yeah. Yes.
Right? So we again go back to electronegativity. If the location which is going to be acting as a donator is less electronegative, it will inevitably be a better nucleophilic system as well. That is why in the phenoxide ion case, I mentioned that the ring is a better location as a nucleophile. You remember this phenoxide ion case?
Yes, sir. Yeah.
Why did I mention the ring is better? Because the carbon will be less solvated. This O minus ending here is going to be much more solvated. Whereas these locations are not going to be that well solvated.
Yes, sir. Yeah.
Because the ring will repel any oxygen nearby. Hydrogen to aega, but ring will repel the oxygen flow of far more. And you are having these locations being much less electronegative
Yes, sir.
because they are carbons, which means they don't attract that many water molecules in the first place.
Yeah.
You understand the idea here? Huh? So now you tell me which among the two is more preferred.
And it's
From either way, whichever way you look at it, the nitrogen is better, right?
yes, sir. Yeah. So,
So
but then there's a chance of us also attacking it. I mean, slight
there is no
minor.
chance. But why would you care about that
Yeah.
as a possibility?
I'm just okay. Yeah.
Now,
Okay.
what is among the other options given there in the question? Do you have a problem?
No, sir. No. I got the answer. But, yeah.
You understand that the ring will not be touched, right?
Yes, sir. I won't be touched. Yeah.
So that bromine on the ring is not going to be hit at all.
Exactly. Yeah.
That part
Yes.
is clear, right?
That'll stay similar. Yes.
Cool. Okay, next.
1 second.
Have you started having fun with questions?
Slightly. Yeah. I completed like a decent amount in this.
Because ultimately that is the way to measure your progress, I would say. Your
Yeah.
actual progress.
Then yeah. Yes.
How are your previous chapters?
Uh, like hydrocarbons is a little weak. I still have to practice questions in that. I haven't done many.
Hydrocarbons, I'm quite sure they would have done what to say, elimination internal, all of that nonsense.
Yes, sir. They,
The Esterwala elimination, all of that crap has also been discussed, I'm sure, in your school.
yes, yes,
You've done those, I suppose.
yes, sir.
And you're clear with them?
Uh, the EI part, I am like I not that clear
They
on
did
it.
the amine oxide or they did the ester one or both?
So amine oxide, they did, I guess. Yeah.
Hmm?
Amine
Amine,
oxide. Yes, sir.
amine oxide they did. Ester one did they do or only amine oxide?
I don't remember them doing this.
Okay, all right. Ask your doubts, then I'll poke.
Okay, sir.
Normally, in the last 2-3 sessions, I've been leaving you with more what to say, vagueness than clarity. I
Yes, sir.
will at least leave you with more clarity this time.
Okay.
So,
Yeah. So like we started aryl halides yesterday, so I think metal Vignas age will have.
so alkyl halides, aryl halides, and then Grignard, and they close.
Yeah,
So
I believe that will be.
aminosynthetase also then.
No, sir. I don't like. We'll have online classes in April, but I don't think they'll complete that and give it for the exam.
और छुट्टी है क्या तेरा?
Yes, sir. Yeah.
2-butene reacts with bromine water, resulting bromohydrin and treated methoxide and methanol. Undergoes intramolecular SN2. Butene bromohydrin and treated methoxide and methanol. Okay. Undergoes an intramolecular SN2. Taking into consideration the serial chemical consequences of the reaction mechanism, choose the final product. So Z2-butene. Z is going to be the cis-wild form. Okay. So okay, this burr first forms the bromohydrin. Reacts with bromine water, forms a bromohydrin. Okay, so that this correct. Okay, and I'm going to be having this particular case here, opposite attack here. Okay, so let's start off step by step. Let's not go for the answer there directly. So I'm going to be having 2-butene in the cis form there. So that fellow is going to be targeted by bromine water. So if I'm going to be having bromine water attacking here, what will be the products formed here?
Yes, sir.
What's
That. Sir, what?
these two locations become chiral?
Yes, sir.
So if they become chiral, what are the products formed?
Now, 1
I
second.
will have enantiomers,
Yes, sir.
acidic mixture, right?
Yeah.
So if I do get a racemic mixture there, I'm going to be having both possibilities clearly available. Yes.
Yes, sir. Yeah.
So once I have that applicable, now in the next case, I'm going to be hitting this with methoxide. The methoxide fellow basically ends up doing this. It will attack this hydrogen, pluck that fellow out, you get an O minus.
Yeah.
So then we end up having the O minus, which is generated here, will go and attack this fellow and kick this guy out, which is going to be resulting in our product over there. Now the question becomes, what is going to be
Oh,
the configuration at each of those locations?
okay, okay,
Right?
okay. Yes, sir. Yeah.
Now I think you are getting closer to the answer directly by yourself.
Yes, yes, yes. I.
What was your issue here? Where did you get stuck?
So
Why did
this
you have a
step,
confusion?
uh, I don't know. Like,
I can see what you have put there. You messed up with putting bromine and bromine.
no, sir. That was something else. I know that was wrong. I should have released
Okay.
that. Yes.
What was the real issue here then? What's the
Um,
answer given here?
sir.
What's the answer for this question?
Second. 1 and 2 are equal amounts. Sir. D, sir.
Huh? That seems fair. Hmm. Why will they be equal amounts, by the way?
So because it'll be, why would they, the,
Racemic mixture.
exactly, yeah. When this thing, why would, yeah.
You're getting enantiomers in equal quantities. So
Exactly, yes. Mm,
you understood what you needed to understand here?
yes, sir, yeah, I could have.
What was your confusion? Let's go there. I thought I would not want to confuse you more, but this is a straightforward question. This should not
Yeah,
have been tough for you.
sir,
Where did
I
you make a mistake?
wasn't like my options were matching when I first did this. I don't think I messed up somewhere in this key. Okay.
This is MS Chauhan.
Yes, sir, yeah.
I thought you would be doing that Akshay series or whatever.
That, no, that blue thing.
You've not yet graduated to that stage yet.
No, no, I didn't.
Okay. उसमें से questions आ रहा है क्या तेरे internal exams में?
Sir, what?
that other book which you sent? Are they
Yes,
asking questions from that, or are they
not
asking questions from MS Chauhan in your weekly exams and all?
sir. From I think Himanshu Pandey they gave few questions.
हिमांशु पांडे से मिल रहा है, ठीक है हाँ.
Yes, sir. Okay, but
Next one.
so I think this is.
You understood what you need to understand here? Yes.
I understood, sir. I understood. Yeah. I said, it, sir.
The following groups is the strongest. Right. Which group you have a problem with?
Sir, my answer is not matching with the thing.
Okay, all right. Okay. Okay, so CH3O minus, C2H5O minus, CH3S minus, and methanol. In the first bunch there, second fellow is the best guy.
Hmm.
Okay, so that directly gives answer as well. So not second fellow, third fellow is the best guy. Damn. S minus is
Yeah,
better. Yeah.
so
So third guy, that means that is 1 and D. A and D. Okay, so two possibilities open up. So among the two possibilities, we are having, oh, everything is nice and different. Okay, let's look at the second one. DMF. DMF. DMF is going to be NH2 minus, which is best, clearly.
yeah, that's what. But it's given OH minus is better.
What?
Yeah, the key is given OH minus is better.
Right. Maybe I screwed up. Let's see. Dimethyl formamide, right? So, formamide. Okay. So, formamide, dimethyl. This is proper polar aprotic.
Yeah, that's what I was thinking. Obviously, it will be NH2 minus with them.
NH2 minus, they're fucked up.
Okay,
NH2
fine.
is better there. And let's look at the third one there. Third one also should be,
CH3.
third one also should be 3.
Yeah, that's 3.
The answers are wrong, done. It should be 333.
Yeah, that's what I was thinking. Okay.
Answers are wrong here. They gave Delhi as the correct answer or A as the correct
Yeah.
answer?
Delhi, sir, Delhi. Yeah.
They've got both parts there slightly wrong. All three should be 333.
Yes, sir. Yeah.
Okay. None of the answers are correct actually.
Yeah, that's right.
Okay. Next one.
Um,
So your logic is not wrong here. It's fine. It's correct.
yeah. The second part.
What will be the effect of increasing solvent polarity on the rate of each of the following reactions? The second thing is a problem, is it? B.
Yes, sir. Yeah.
Okay. RL plus R plus L. Increasing solvent polarity. So when I'm increasing solvent polarity, what will happen? What will happen?
Um,
Why is the first one getting better according to you if you increase solvent polarity? You
so
marked it as
that also. Yes, sir. Yeah.
why?
Sir, I thought the like the more stable, like the
Which is more stable?
sir what?
When you say stable, what do you mean by stable? Which gets better? If I increase solvent polarity, what is going to be more stable? Charged species,
Charge species. Yes.
correct? Because when I increase
Right.
solvent polarity, that means the charged fellows are going to be more nicely solvated.
Exactly. Yes.
So
Yeah.
in the first thing there, the logic should be that it has nothing to do with cation pools L minus and whatever we have scribbled there. The idea
Yeah.
there is your products are more stable in the what to say system where there is more polarity, which means forward direction is favored. You understand how to see that?
Okay.
Now apply the same logic in the second case there.
Hmm. Then
The leaving group does not have a negative charge.
yes,
Both my
but
systems are having a positive charge.
yeah,
Reactant and the product.
yeah,
Right. So
yes,
in this particular case here, solvent polarity increasing should not really affect both sides by beyond, what to say, it should not really change it too much. If it does favor something, it will probably favor RL plus remaining as it is. Backward is probably going to be more favor because the L is leaving with the lone pair, and I don't know how stable the R plus is going to be. Technically, though, yeah, it should not matter. I would say solvent polarity here might decrease over here if I'm increasing solvent polarity. What is the answer given for Bombay?
that's given decreasing sign.
Yeah, that makes more sense. Why it makes more sense over here is because you're going to be having octet configuration retained only in the reactance side. If I'm taking the R, let me put it down here and show. If I take this system, all right, in this here,
Yes.
both sides are going to be favored by the solvent being more polar. That is, I'm going to be having this guy and this guy. Both are going to be better in terms of favorability. But if I consider the reaction as an equilibrium,
Hmm.
now I'm going to be considering that both of these are going to become more stable. Which one's stability is going to be more important now? Which one is
And
inherently better? The RL plus is
the
inherently more stable than the R plus. Why? Because the L is taking the lone pair and getting out, right?
hmm.
That means this R plus does not have octet.
Okay, okay.
So think like this. You know, during the COVID time, cash was pumped everywhere.
Yeah,
Who really got richer? When cash was given everywhere, what did people
yeah,
do? People had extra cash. What did they do
yes,
with extra cash? They parked it,
yes, exactly.
park it
Yeah,
in assets,
yeah,
in stuff, in luxury
yes,
goods, and in stocks and
yes.
bonds.
Yeah,
Who did they really benefit? The people who owned the companies which made all of that shit.
exactly. Yeah.
And the people who owned the companies of which the stock which was bought, they benefited a lot more.
Yes. So done the yeah.
Right?
Yes, sir.
So in this particular case here, when you are making both sides extra stable, the one which is inherently more stable will benefit a lot more.
Hmm. Okay.
If I'm going to be having the system now, currently it's in equilibrium. Everything is equilibrium.
Yeah.
So this guy is in equilibrium. In that equilibrium, I'm going to be having something now added in, which is benefiting both sides, reactants and products.
Hmm. Yes.
Not by what to say, it's giving both of them an extra benefiting factor, like say an X multiplying factor. When you give both of them a multiplying factor, the one which is already more stable will benefit by a huge margin, by a much larger margin, because the multiplying factor is what is added here. It is not an additive factor.
Okay.
That's why the analogy I gave was the COVID thing either.
Good. Yes.
Think during COVID, what happened? Who became richest fellow for a while? Louis Vuitton dude.
Yeah.
Why? Because people went and bought his products.
Yes, exactly. Yeah.
Amazon dude became extremely rich. Why? Because people went and bought stock.
Yeah.
But the money was given
Yeah.
to whom? Were they given the money? No. The
No.
money was given to common people. In the
Yes.
world, across the world, people, the countries printed money, they gave it to common people. The common people went and bought these things.
Yeah.
So the person who was already more stable became even more stable.
Yeah. Yes.
You understand the idea here,
Okay.
right? In this case here, both are going to become more stable. I'm not saying the products are not going to be more stable here in the polar protic solvent, if I'm increasing polarity here. But the reactant stability is becoming even more enhanced compared to the products,
Yes. Yeah.
which is
Correct.
why it's
Yes.
going in that way, not because of any
So.
other reason.
Okay.
You have to go with
Yeah.
Leshat. What was your doubt here? Your doubt probably was along the lines of carbocation should be, or the R plus should be more stable in a polar protic solvent. So why is it
Yeah.
not going more in forward? Is that the doubt there?
Yeah. It was something like that. And plus, like, we wouldn't really know whether the R is stable or not, right?
That's the point here, now. When
Yes,
I
sir.
don't know whether the R plus is stable or not, but I damn well know the RL plus has octet.
Yes. Yes.
For damn sure, I know that will have octet, right?
Yes, sir. So
The
if
R
that
plus
were, hmm,
may, does not is not the correct thing there. I should not have used does not over there. May not would have been a better term.
sir, in some cases that this would, like, if there was like a tertiary carbocation, then would it still
See,
decrease?
let me put it over here in a way in which it will basically give you the answer you're looking for. You're asking when is a possibility that this might
Exactly.
be pushed in forward. Is that what you're asking?
Yes, sir. Yeah.
If my RL plus is going to be having the L attached to an extremely heavy sterically hindered site, which
Yeah.
hinders my solvation for the RL plus. But solvation is
Okay.
possible for R plus. In that case, it might go in forward.
Okay.
You
Okay, sir.
understand what I just said, or should I repeat it?
Yes. No, I got it. Yes.
So only in that case, only in those kind of cases, where I'm going to be having the RL plus because of steric factors is going, if that becomes a problematic location for solvation, then I will end up having possibility of forward direction being more. In almost all other cases, it will be backward only.
Okay.
Next, you understood what you needed here?
Yes, sir. Yeah, I got it.
Okay, next one.
1 second.
You're in fine form, dude. You've not asked shitty questions. You've asked some decent questions today. Means you're
Yes.
starting to understand organic quite nicely then.
Yes, sir. Yeah. Sir, I still feel my hydrocarbons is pretty weak though.
There's nothing wrong with feeling hydrocarbons as weak because that is the starting part there. Your connections to hydrocarbons are starting to be formed. So relax.
Yeah, after SN1, SN2 started, I started feeling a little comfortable. Like,
Because you started making connections properly now.
yeah, and then I could like finally understand like even E properly, like elimination. Like back then, I didn't really clearly understand, but now I feel like I've gotten more clarity on that
Yes,
due to
because you didn't
SN1. Yeah.
you're not supposed to have understood that because nothing was
Okay.
given there as information. Nah.
Yeah. Yes.
The connections all come in alkyl halides here. In fact, aldehydes and ketones may it will get better.
Hmm.
Oh, okay, what is this? Nitration
So,
order. Yes.
so like for an exam, like how do you like? What would you advise? Like, how would you advise me to revise for
For which
alkanes and
exam?
for the like a final exam we have, right?
This
Grand test.
exam.
Yes, sir. Yeah.
Okay.
We only
When
have
is the
organic.
exact
Yeah.
exam?
27th, sir.
April?
Yes, sir. Yeah.
March 27th or April 27th?
April, sir.
April 27th. By that time, what is the expectation of them completing how much?
Gigna Jason, sir, until then.
Only up to there.
I think so. Wait, 1 second. I'm pretty sure it'll be up till there, but
Gets
then
and P1s gets in, or
I don't think it'll come, sir. I'm pretty sure it won't come. 1 second. So like we started Arail Heritage yesterday, so I think maybe Gigna Jason will have.
so alkyl halides, aryl halides, and then Grignard, and they close.
Yeah,
So
I
I'm
believe
for
that will be.
phenols also then.
No, sir. I don't like. We'll have online classes in April, but I don't think they'll complete that and give it for the exam.
और छुट्टी है क्या तेरा?
Yes, sir. Yeah.
Tell me what your question was. You want to know about what? Preparation, something, right? What was it?
Yes, sir.
How to prepare? Huh?
Yes, sir. Like, what would be like a nice? What?
First off, I would recommend that you do not put your hopes too much. First is that, because I can sense this question basically means you are sensing that you are getting better and you are planning on using that examination as a possible way to boost your confidence. Do not. First thing, keep that away. Keep preparation and results separate. That's what I would first recommend. Result jo bhi aayega, aayega. Your benchmark has to be, are you getting better progressively? Are you getting more comfortable with the subject progressively? Now, preparation wise, what can you do? Mental preparation is the most critical thing, as I said first, because if you put your basket, put your eggs in this basket, you might get crushed. What I would first say is go with that. Chill out about the result. Now, coming to the actual chemistry preparation part here, synopsis, write down, memorize them. If you want to score more marks in that exam, you will have to focus on unnecessary exceptions, unnecessary weird crap. If you want to prepare properly, go with what you're doing. You're doing quite well. The fact that you are getting more and more confident and more comfortable with solving questions, that is the right path to take. Keep following that. Don't assume that you have to change. You don't need to change so much. If you're getting more comfortable, is that a wrong sense or is that a correct sense here?
No, sir. It's right. I'm feeling like doing chemistry more often
Don't
nowadays.
change too much. What you're doing is working. So stick with it. Why did you ask this question?
Sir, like previous,
That is why
last
I
year's
went to
middle.
that mental crap. I would not have gone into that shit at all if you had not asked this question. Why did you ask
Yes, sir.
this? That's
Because like
a question which someone who is getting more and more comfortable should be asking.
no, I was just asking because like my hydrocarbons like not too good at that. I don't know how to go about studying that chapter again. Like those chapters.
Hydrocarbons, ma'am, did you sit and solve questions in that like this
No, sir, I
properly or
didn't.
not?
Sir.
Then
No,
वही
I
तो
didn't.
करना है ना तुम्हें और क्या करना है?
I mean, there's
No,
a lot to like remember as well. Like,
that's why you have written a synopsis. I remember you were already writing synopsis for hydrocarbons at that time.
yes, sir. Yeah.
Properly लिखा तो होगा ना तो
Yes, sir.
refine that more and memorize it. There is no escape, bro. Organic chemistry, there is no escape from stuffing your brain with information. First step is stuffing your brain with information. Then, as you practice, you will start realizing which of the crap you can throw out.
Hmm.
When you're practicing here in alkyl halides, you're starting to realize what are the stuff which you need to actually memorize and actually remember.
Yes, sir. That's correct.
Your brain is automatically deleting shit which is not necessary.
Yeah.
So that's the same way it works in other chapters as well. You have to do the same thing only. There is no difference. If you're getting more comfortable, that means you're following the correct path. All you have to do is Go with that same path in that other chapter as well. If you're not feeling comfortable, that means you have not completed this path in that other chapter. Yes or no?
Yes, sir.
Then you have to do that. And you're saying you're going to be getting holidays.
Yeah,
All I
supposedly.
would say is sit and solve the full goddamn MS Chauhan as much as you can. That seems to be giving you weird confidence. I don't know why, but it is giving you confidence. No, it is working.
Yeah,
And
somewhat, yes.
that is what you want, no?
Yes, sir.
So I still have the question. Why did you ask the question?
So mainly just like
Was I right in assuming that you're trying to bank your shit on that exam?
kind of.
That is not
Yeah.
worth it. Avoid, diverse yourself from the result. Because I can sense frustration in you that yes, you are feeling more comfortable, but अब तक जो results आया है वाट लगा है.
Yeah.
That is a scary path to go down. Because when you start putting the outcome ahead of the path which you are taking, your brain will stop producing dopamine for the path. And it will start producing dopamine only for the outcome. That is not the right path right now. Not now. I'm not saying you should not put the outcome ahead. You should, but not for some internal exam. You should put the outcome ahead when it comes to actual JEE mains. That's going to happen anyway in January. उस टाइम पे समझ में आएगा कि क्या औकात है क्या नहीं है. And you get another chance also anyway in March, April. Why should you worry so much then? You have enough opportunity. And if you really want to put your things in a proper examination, never for an internal exam, only outside exams. Apply for KVPY, apply for chemistry Olympiad in the next year properly. Write them. Or you want to check out how you are doing, go take old KVPY paper, which you should, I think you know what KVPY is, no? Do
Yes,
they
sir.
still conduct those exams or that is not happening anymore?
No, sir. They stopped it.
The exams are happening or the scholarship is gone?
No,
Exam,
they stopped the exam at all. As of
exam
now.
itself is scrapped.
Yeah, NTSA. So, yeah.
AMTA is also scrapped.
Sir, what?
AMTA is also scrapped.
I'm not sure what that is, sir.
Okay, so Olympiad का पेपर तो होगा तेरे पास, वो तो चल रहा
Oh,
होगा.
yeah. Yes, sir.
Did you write the? I remember you did not write the chemistry Olympiad.
I
You
did
went
not read
for
it, sir.
physics and
Yes,
astronomy,
sir.
right?
Not astronomy, sir. Only physics.
Only physics. Okay.
Yes, sir.
Why would you go write physics? That would have been your most uncomfortable one.
Yeah. It was pretty easy, though, actually. It wasn't that difficult.
Then go try out the questions in that.
Okay,
And
sir.
more critically, if you want a benchmark to measure yourself up against, truly, to see if you're going in the correct path. Because that is what I can sense you want basically, more than anything else. Because
Yes, sir.
yes, you're feeling more comfortable, but you want validation from your own self that you are in the
Yeah.
right path. Exam
Yes,
is
sir.
not the way to go. You finish your, what to say, alkyl halides and all of that. Then you take an archive, old JEE
Yeah.
archive, sit and check there. That is the right
Hmm.
check there. Because internal exams are good, especially in this kind of an exam where they are purposely clubbing topics. They are only, teachers are only interested in fucking the students. That's the directive which they have been given.
Hmm.
One paper is basically screw them completely. One paper give them hope.
Yeah.
So you should not bank on the results. If the results come, wonderful. But you should not put your mental strength on that result. Not for your own validation. That has very high probability of kicking you in the nether region, so to say. So mentally, you will have to make sure you're not looking for validation from that exam. You want validation mentally that you're on the right path. Do not check your archive questions now when you're solving. Solve MS Chauhan, solve Himanshu Pandey, whatever you're solving. Continue down your path. Finish solving whatever you need to solve for all the chapters. Get comfortable in your brain with them. Then take time out, say maybe 1 or 2 days specifically, only sit and try out archive questions. See if you are able to, what to say, see if you are more comfortable in those topics than how you used to be earlier. That is a way to basically check whether you're on the correct path or not, to give yourself validation. I sincerely would not recommend putting your hopes on that exam, because I know what kind of directive teachers will be given in that exam. And the directive was unfortunately what I said, will unfortunately be what I said. Or if they feel the kids are doing very badly, the directive will be make the exam paper easier. But I don't think that will be the general,
Yeah.
not for
Yeah.
topper batches.
Yeah.
For topper batches, the game is always going to be give them a little bit of hope in one paper, smash them to pieces in the next one.
Yeah.
I'm guessing all the papers you have written will be like similar to that experience, right?
Yes,
एक
sir.
पेपर में थोड़ा बहुत आएगा, एक पेपर में वार्ड लगा देंगे.
Yes, sir. That's right.
So that is the general. टॉपर्स के लिए वो चाहिए.
Mhm.
They should never feel comfortable. And हाँ, your validation which you want that you are on the right path has to come from actual exam, not internal. Internal, there are many ways to screw an organic graph. There's too much. There's, for God's sake, you're feeling comfortable in alkyl halides, no? I
Yeah.
will send you something which will mentally screw you up if you are interested in trying. Why should I send you?
Okay.
The teacher has already given you that Akshay book or whatever. That will give
Yes, sir.
you. Think if they are asking only questions from that type of a book, only
Mhm.
exceptions show up. How can you expect yourself to score marks, man? You're not going to be scoring if that happens. So focus on actual JE questions. Do not care about internals for a while. Organically, you are not supposed to care, because as I mentioned in the beginning, when you are starting with organic, you are behind already. There will be fools who also understand that this is the game, and they will prepare for that also. They can,
Mhm.
for a fact in your class, there are kids who have already solved MS Chauhan when they've probably just, what to say, sure, there are kids in your batch. At least the topper fellows would have definitely solved off MS Chauhan halfway by the time you are starting organic.
Yeah, maybe.
And they would have moved on to that blue color book which your teacher has sent around. They are going to be having more information in their brains. That doesn't mean they are better off from a JE standpoint. But at the same time, you should not discount the fact that JE is the game you are playing. You are not playing an internal exam game. You should not. Thoda lagega, it is painful to accept that internal exams, you should not focus so much, mainly because that gives you a lot of pain in the short term. If your results don't show up there, I'm sure your parents will harass you. But I don't think your parents are that type though. Doesn't feel like that.
Yeah,
You
they
harass your
were.
more, I think.
Yeah.
So that is what I would recommend from preparation standpoint. You want your validation, get it through actual exam. JE का archive उठा के उसमें से solve करो. That will give you a more clearer idea whether you are on the correct path or not. Now, next, what else do you have?
So I think I said the next question.
See, that is especially true for organic chemistry and inorganic chemistry. If this was a physical chemistry paper, I would recommend you can put your eggs in that basket. You should focus, because physical chemistry is like physics. They can't really,
Mhm.
even if they screw you, you need to know it.
Yeah.
And it's logical only. Organic lab,
Mhm.
the way they screw is by giving exceptions and facts. That is the problem there.
Yeah.
And
Yes, sir.
that you should not bank on. Okay, now next.
Yeah, sentence.
Sorry if that was not the answer you were looking for.
No, sir. Nothing. No.
You have more questions?
Yes, sir. I sent it.
You sent up. You look more morose. Why do you look more defeated? Oh, you already sent that question, nitration order, na?
Yes, sir. Yeah.
हाँ, okay. उसमें क्या problem है तेरा? This looks quite straightforward and easy.
So I think the key might be wrong. Please. Not key, but like,
What is the answer given here? Nitration order. They should have given you answer as option one is best. Order पूछा है ना? ठीक है.
yes, sir.
One, one greater than three, greater than not three. Sorry, one greater than four, greater than three, greater than two.
So they gave 4 greater than 1. That's why. Yes.
They gave four greater than one.
Yeah.
No, that's not correct.
Sir, how are you saying that
Okay, okay, once
two
again,
should
once
be
again.
greater than 4?
Four greater than one. Okay. Hmm. Mhm. Possibility though, है. Four greater than one is possible. I might be wrong
Then
there.
how is it?
Four may you're going to be having no electron withdrawing, nada?
Yes, sir.
Not
Yeah.
directly attached to the benzene ring.
Yeah.
So yes, in the first one there, the oxygen which is directly donating might be a better donator. Actually, I will still probably go with one greater than four only. But technically speaking, the idea behind which they have basically given four greater than one is probably going to be that in four, the benzene ring has totally more electron density. Why would it definitely have more electron density in total compared to one? Mainly because you're going to be having in the fourth one there, the C double bond O is not going to be withdrawing from the ring directly.
Hmm.
The C double bond O is withdrawing from the oxygen there, correct?
Yes. Yeah.
But it is not withdrawing from the ring directly.
Yes,
In
sir.
the case of option one, it is withdrawing from the ring.
Correct.
I still think one will be slightly better than four, mainly because the location which is going to be targeted are not the same. The C double bond O, the oxygen over here, let me draw it and show. In this case here, this oxygen is going to be mainly, what to say, helping this location. And this location is meta with respect to this, right? So
Yes.
I would still, no, I would not say that one is better than four. There is a possibility that four might be better than one. They might not be wrong here. Mainly because yes, this oxygen is supporting, what to say, this location definitely, and it is meta with respect to the carbonyl. But the main reason why, if they're given four as better than one, it would be this. This C double bond O is withdrawing from the ring,
Yeah. Correct.
and it decreases the net electron density on the ring.
Yes, sir. Yeah.
Whereas in the case of four, the net electron density on the ring is going to be enhanced only, because there's a methyl over there or a carbon over there, which is definitely going to be, yes, not that good a donator, but at least a donator by hyperconjugation. So you're going to be having both being donators here, which means this ring is going to be more electron rich compared to the ring in one. But I feel the location in one, which is this para location here, might be better in one for attack. It might be better in one for attack. It will probably give better yield also. It will probably give better yield also. It might give slightly faster. It might give more faster reaction compared to this. I'll actually go with what I gave as the answer, not four better than one, because they are asking nitration order over here bluntly, right? That's all they have
Yes.
mentioned. Huh?
Yeah.
Oh, dude, there's supposed to be a max class for you, da.
I don't think so.
He sent message at 11 o'clock for 10:30 a.m. class.
Oh, sir, she told me again that it's in the evening.
Huh, sorry?
It's in the evening apparently. Yeah,
Oh, evening only. Okay, so that is wrong message only.
yeah, I just saw it.
Just saw that message and I was like, oh. Yeah. I still go by one better than four here, Raj. Mainly because in this particular case here, whenever you are looking at EAS, the final thing which you should do is attack the fellow with the electrophile, get the carbocation, check the stability. And in this case here, I would say that the one fellow will result in a slightly more stable carbocation. It should. But their logic is possible. I cannot say that they are completely wrong. There is a good chance they are right here. So I am not 100% sure of what is the answer here. But if I have to bet, I would go with one better than four.
Hmm.
But yeah, there is a chance I'm wrong here. There is a reasonably good chance that I'm wrong here. Reasonable chance at least. I would not say good, reasonable chance that I'm wrong here because the fourth ring will have more electron density, which means nucleophiles will be attracted more strongly to the ring on four. But
Yes.
my
Yeah.
gut feeling is the nucleophile will prefer to target the location on the ring on one more than that location on the ring on four. Huh.
Hmm.
But there is definitely going to be controversy here. They have a good chance of being correct here. What is the answer given as of now? Remaining parts are the same, is it?
Yes, sir. Yeah. Yes.
Then, they
For
are.
132.
There's possibility. Which book is this?
Sir, I'm not sure, sir. It came in a question paper. My friend sent it to me.
Exam paper. Huh?
Yes, sir. Yeah.
And which exam was this? Internal or external?
Sir, I use a shuffling test for CM batch, sir. For the
Then
mother
they
paper.
have definitely had enough arguments over there.
Yeah.
Go with what? No, no, no. I'm not joking. I know how much arguments happen in these kinds of places. I used to be one of the assholes who used to give these kind of unnecessary controversial questions as well. So I used to have tremendous arguments every time. If they have argued it out and they have finalized that this is the answer, they are mostly correct. Somebody would have checked the data there and
Okay.
then
Yeah.
only confirmed it. Then we go with four itself. Go with four. So this was in a proper important exam then, correct?
Yes, sir. Yeah.
And this had enough arguments happening, or it was only internal एक ही या दो ही batch लिखा था?
Sir, like the CM batch is three batches, sir. All three, right? Yeah.
No. My question was, were there different faculties over there who were arguing, or was it just one main dude who was basically like taking command?
I think it's one main person. Yes, sir.
Then no. Then I will still stand by what I went with there. If they've had arguments and then they have decided, that is one thing. If there has been very limited arguments and they have just randomly accepted, then yeah, I will stand by my answer.
Okay, sir. Yeah.
So there is controversy. I will agree with that. Was the other there was another option which had one greater than four, or they did not have that?
Sir, actually, the options were like not exact order, but 1 second. Let's see. So it was like A was 2 greater than 1, B was 3 greater than 2, C was 4 greater than 3, and then D was 4 greater than 2. This in the photo. 1 second.
So send me the options. So one greater than four is not there at all.
Yeah, it's not. Yeah, it was.
Then it's fair only.
Yes,
Then it's
yeah.
perfectly acceptable. Because 1 and 4 are the controversial fellows here. Remaining are all fairly straightforward. Relatively straightforward.
Okay.
Huh.
Yes.
Only 1 and 4 are controversial. Mainly
Yes.
those two are controversial. And yes, I would still stand by 1 is slightly better than 4. Only the ring will be more electron rich in 4. Overall ring. Location will be better off in 1. Location will be far better off in 1.
Hmm. Okay.
So I stand by my answer there. 1 greater than 4, greater than 3, greater than 2.
Okay, sir.
1, 4, 3, 2. Correct. So we'll be having 4 greater than 3, 4 greater than 2 are both correct. 3 greater than 2 is also correct. 2 greater than 1 is wrong. So BCD answer is good.
Uh, I don't have the keys.
But चलो हाँ BCD होगा हाँ चलो हाँ.
Yeah, probably.
So this has been cleverly given.
Yes, sir. Yeah.
That means the teacher also understood that there is shit over here and he did not want to argue.
Yeah.
Okay, next.
I think it's.
Yeah, you see. Relative rate of reaction of the following amine methyl iodide. Methyl iodide. Okay. So if I'm going to be considering methyl iodide, reaction with say nitrogen, this fellow will go attack over here, and we will end up having a product obtained after multiple attacks. So A is going to be probably the worst here. B will probably be best. C will be second best. Answer is option C. What is given?
Yes, sir. Yeah, see, sir.
Okay, the logic will go like this. Why is B best first? Why is B better than A? Let's look at that. Why is B better than A? Because in B, the lone pair has enough space, right?
Hmm.
In a sense, the nitrogen is on a bridge location, correct?
Yeah.
If it's on a bridge location, you're going to be having the 3 bonds are going to be constrained, but the lone pair is freer. Do you understand why?
Uh,
Think like this. Let's go with option A first. I mean, let's go look at the compound A first. In compound A, I'm going to be having 4 bulky fellows surrounding the nitrogen, correct?
yeah. Yes. Okay.
Which are the bigger fellows though? Is the lone pair bigger or are the groups bigger?
Groups.
Groups are bigger, right? So the groups
Yes.
will be pushing the lone pair into a corner. The groups will occupy maximum space. That means when this guy is going to go target the methyl location there, it has to go target it with that group or with the lone pair.
Hmm.
With the lone pair.
Yes, sir.
So when it is going and targeting with that lone pair there, the groups are going to be hindering the what to say attack over there. If the groups can be pushed a little bit more to one corner and the lone pair is having more space, then the lone pair can attack that particular methyl location better. Does that make sense?
Yes.
So now come to compound B. What is happening to the groups that are attached to the nitrogen there? They're all constrained and held in a tight chain-like fashion
Yes.
out
Yeah.
of the bicyclo.
Yes, sir.
That means the space they occupy is now forcibly constrained,
Hmm.
which means the lone pair gets all the extra space because that gets also a fat zone.
Hmm. Okay. 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 Understood.
So B will be better than A. Now we go to why C is worse than B. Why is C worse than B?
1 second. I'll do this. Hmm. It should be better, I think.
So why is C worse than B?
So lone pair repulsion something.
No, because the other nitrogen is a goddamn minus A group.
Oh, sir, but then okay, okay, okay,
That's all.
okay,
Two
okay,
lone pairs
okay.
doesn't mean it is going to be better, right?
Yes, sir. Yeah.
The minus A effect is what matters over here now. Hence, C is worse off than B.
Okay. Hmm.
You understood what he wanted here?
Yes, sir. Yeah. So the first one, the lone pair gets pushed into a corner. That's why it's not very mobile.
Yes, it is not that good at being the attacking fellow there.
Okay. Hmm.
Whereas in the second compound, the other groups are now constrained into a lesser space forcibly because of the bicycler part there, because of it being the bridge location. For instance,
Okay.
think like this. If I look at a tertiary carbanion, when can a tertiary carbanion form? Tertiary carbanion, not carbocation. When is it possible for a tertiary carbanion to be possible? When you have that fellow being a bridge,
Correct. Yes. Yeah.
right?
Hmm.
Why? Because the lone pair will have more space. And the groups
Okay.
are not going to be repelling with the lone pair too much. Because the lone pair will have repulsions with the groups, right?
Hmm.
So if you want a tertiary carbanion to exist, it will not exist normally. If you want it to forcibly exist, you would prefer to put it on one of these kind of bridgehead type of location. That is feasible at least, because the lone pair will at least have more space to exist in. Same thing applies over here. The nitrogen will be better off here as a base, as a nucleophile. You understood what you wanted here?
Hmm. Okay, sir. Yeah. Got it. Yeah.
But I think I've left you with one more question or some more questions. But chalo, haan, okay. Haan.
Yeah.
So next,
Okay. So I think in this one, is there like a
you have sent something. I'll
yes, sir. I said it. Yeah.
got it.
NC and CN some differences.
Oh, this is okay. This is fairly straightforward. I'll just quickly explain this. This is going to be the case for both potassium and silver when it comes to cyanide and nitrophilose also. Okay. The idea here is about covalent character in the bond. For instance, I'm going to be having KCN. If I take KCN, this will break into K plus and cyanide properly. Okay. So when it breaks into K plus and cyanide properly, what is cyanide going to be? Cyanide is going to be something where you're going to be having lone pairs on both locations.
Ambident.
And the carbon is the one which is obviously going to be with a minus, much less
Yes.
electronegative than nitrogen, far better nucleophile and basic location than nitrogen. So the
Yeah.
carbon will be the attacking ending. This will be the one which is going to be attacking. This will go attack.
Okay.
Now,
Yeah.
if I have silver cyanide on the other hand, the problem there is that bugger is not ionic properly. Where is silver in your metal reactivity series? You know your metal reactivity series from 10th standard?
Yes, sir. Once again.
You remember at least, right?
That's pretty high. Yeah.
Much lower than potassium, below
Yes.
hydrogen, correct?
Yes.
What does that tell you? It tells you that the fellows at the bottom are going to be predominantly forming bonds which have much higher covalent character.
So can you repeat?
When you're looking at the metal reactivity series, let's just quickly put it down. It will be something like cesium, rubidium, dot dot dot. You'll have potassium. नहीं होगा. हम यहाँ पे होगा. Then you'll have barium वाला bunch. You'll end up having G. This is going to be your metal reactivity series, more or less.
Yes. Yeah.
In this here, what is going to be happening here? We'll end up having all of the top buggers being extremely reactive. They will form purely ionic species. If you look at the ores, these guys are predominantly found in salt water because they are extremely highly ionic fellows. They'll form bonds with halides predominant, especially the top bunch here. This middle bunch here, calcium, this bunch here, these fellows will form oxides and stuff.
Yeah.
Calcium, for instance, they are formed as calcium carbonate, calcium oxide मिलता है, aluminum का oxide मिलता है, वो सब मिलता है. They are their main ores, etc. Same goes for iron, etc. These will also go for oxides. Basically, the idea here is the compounds the species form will move in terms of ionic character. You remember Fajan's rules?
Yes, sir. Yeah.
Now, think. I mentioned the top fellows, this bunch here, predominantly form halides. Why? Because the halide ion will have only a -1 charge. That means with the halide ion, these guys will be far more ionic. When you go down here, these buggers, aluminium, zinc, iron, what are the most common ores for them? All oxide fellows, right?
Yes, sir. Yeah.
Oxide. How is oxide different from halide? Oxide, it's a -2 charge.
-2. Yes.
That
But
means
only minus.
the rules tells us that should have slightly more covalent character than the halide.
Covalent. Yes.
Slightly more, not much more. It is also ionic only, but it will have more covalent character than halide. So these fellows prefer to form that. As you go even more down, you will only start seeing that these fellows will try to form sulfides. You will start seeing lead ke liye the main ore is galena, which is PBS.
TBS. Yeah.
And you will end up having these fellows predominantly forming sulfide fellows here. Why? Because sulfide is larger than oxide in size as an ion, which means it is even more covalent character.
Okay.
If you go down even more, what will these fellows do? They don't form ores. Why? Because for them, they cannot even think of forming an ionic bond. It's very bad for them. These fellows will only exist in ionic species when you're going to be having coordination complexes and stuff stabilizing them. Otherwise, they will not become ions. Silver is going to be something which is going to be having much higher covalent character. So the bond it forms with carbon will be nearly covalent. So what happens now is there is no C carbon minus. Only the nitrogen can go attack. You understand what I mean over here? So if I'm going to be having this guy reacting with something like this, what will happen? Nitrogen will go attack over here, and this will go.
Nitrogen.
RNC. ये मिलेगा मुझे product में. Whereas if I did this fellow with R leaving group over here, this carbon ending will come and attack here. And this will be giving me RCN.
Okay.
You understand what I'm trying to explain here?
Yes, sir. Yeah.
The same thing applies when you're going to be having nitro. For instance, if I say have KNO2, this will break up, give me K plus and NO2 minus, resulting in nitrogen. It will be like this. It will be like this. Which will go attack now? In this.
Sir, what? Can you repeat?
If I'm having this species here, nitrate ion, this is my NO2 minus ion.
Yeah.
Which ending will go attack here? Which ending is more nucleophilic here?
The minus. Sorry, the
O minus.
yeah, minus.
O minus.
Correct.
So O minus will go attack over here. Remember, the nitrogen is here in sp2, full-fledged. This oxygen is only partially in sp2, resonance case of say.
Yes. Yeah.
Predominantly sp3, but with a negative charge as well. So obviously the oxygen is less electronegative compared to the sp2 nitrogen. The difference electronegativity is not that high between nitrogen and oxygen. They are both towards the highly electronegative fellows. So the oxygen's electronegativity has decreased here, nitrogen's has increased here. So the O minus is definitely going to be something which will be the more better attacking fellow here. So if I have say R and a leaving group, this O minus will come attack, this will get out, resulting in my product being RONO.
Okay, okay.
If I have silver nitrate on the other hand, that is like this already,
Okay, the
right?
lone pair will go attack.
Now which will go attack?
The lone pair. Or
Will
the
go attack. Nitrogen will go attack.
yes.
Which means in this case here, this bugger will go, this will get out, and then this will get out. Usually, if I want silver ka reaction karne ke liye, I will have to have the leaving group being something which won't precipitate with silver, like say silver chloride. I should not have fluorine as a leaving group there. Chloride, bromide, or iodide is better because silver halide, AgCl, AgBr, AgI are very stable. In fact, AgBr and AgI are even more stable than AgCl. So you'll prefer to have the leaving group there as bromine or iodine in that case when you're doing with silver. And in that case, you'll be getting product as R, N marega, O, O minus, and here. And यहाँ पे तुम्हें नाइट्रेटो अल्केन मिलेगा. You understand the thing over here in these two cases here?
Okay.
Not
Yes.
really, but
Something, yeah.
contemplate a little bit more. Sometimes this nitroalkane is called N-nitroalkane and the nitratoalkane is called O-nitroalkane. Nomenclature. I don't care what is used. You'll have different names. तेरे स्कूल में जो भी यूज कर रहे हैं वो यूज करो. If you want to call it as nitrito, call it nitrito. If they are using it as O-nitroalkane in your school or in your system, go with that. Go with whatever your system's nomenclature is. You still have a question I can see in your brain. What's your issue?
I mean, no, I got it, sir, but okay. I got it, sir. Nothing.
Connect. What did not connect?
Sir, could you go up once? Mm, okay, okay.
Why did you have this as an issue? Somebody confused you?
No, nothing like that. I mean, I had a feeling that this NCCN would be like different, but then I didn't really know exactly what was there. That's why I asked.
Okay.
Okay, fine. I got it. Yeah.
Okay, next one. You understood clearly or you still have
No,
any?
I got it. I got it.
You
I
got it.
sent.
Okay. You have sent. Specified conditions. Substrate X undergoes substitution and elimination reactions to the products A to D. Okay. A, B, C, D are belong. Okay. A and B are isomers, but not enantiomers. C and D are enantiomers. Stereoisomers, not enantiomers. Following the starting theorems. Specified conditions. Straight X. So we are taking X and we are eating the fellow. We're supposed to get four products A, B, C, and D. D are enantiomers, A and B are stereoisomers. A is not an isomer of C. A is not an isomer of C. Okay, so we are heating with water. Just plain heating with water. And there's bromine to kick up. substrate X. Okay. So 2 enantiomers are obtained. What is your issue here? You have to just actually plug them in and check out for each of them. No,
So like
the
in all
problem
of them, realization can happen, right?
active. You know,
Sir, what?
3 may that problem is there, no? That is not cleanly optically active there. If let us say we end up doing SN1, which is the expectation to get C and D, right?
Hmm.
You want to do SN1 to get C and D.
Yes.
If you
Yeah.
do SN1 to get C and D, okay, rearrangement नहीं होगा, rearrangement नहीं होगा, किसी में भी rearrangement नहीं होगा, नहीं, rearrangement,
Can happen, no, sir. Whatever you wanted.
no rearrangement will not happen, right? Why would I do rearrangement in second, third, and fourth option? Second, third, and fourth compound. They're already going to be proper, perfect locations, right? Why would rearrangement happen?
Yeah, you're right. Okay. Hmm.
I'm guessing you've understood that A and B are supposed to be elimination, C and D are supposed to be SN, right?
Yes, sir. I got that. Yeah.
That part is clear.
Yes, sir. That's clear. Yeah.
So if you're going to be having A and B being elimination, that is perfectly fine. You're going to be having 2 different possible products. Aana chahiye. That is possible in which ones here? You will end up having fourth also giving that. Third may you will not get 2 different products. So third is out because third may A and B will be more or less the same. Correct?
Yeah.
Why?
So they won't be the same, no?
What are possibilities for A and B in third?
Double bond being from there and
Is there a
yes.
difference if I put it like this or like this?
Sir,
Yeah,
but then the CH3 and HM at the bottom one,
वहाँ पे बाहर का डाल रहा है क्या? हाँ चलो हाँ, that is बाहर का तो हो सकता है.
yeah, that's right.
बाहर का हो सकता है. I didn't think like that. You're right. That is possible. So we can technically go there. हाँ, हो सकता है वो. So if that is happening, yeah, that is possible. Fair. But if I am doing elimination, the problem is this. My first option will give me how many possible products there?
So A
Will
and
give
B and
double
then
here, or it will give double here. And I will be having यहाँ से निकला ना, यहाँ से निकला है तो over here. So these 2 are different products, right?
yeah.
So these are 2 possibilities. One la enantiomers. Can I get enantiomers there? Yes. Problem
Yeah,
is,
we'll get. Yeah.
I might have funny business happening there. Rearrangement हो सकता है क्या one में? Rearrangement will possibly not happen. Should not happen. There's too much to go. Rearrangement will not happen in one. It's too complicated. It is not going to be that feasible there. So in one, if I'm going to be looking at the product formed over there, I will not get enantiomers. I will get diastereomers. Why will I get diastereomers? One like this can be A and B, right?
Yeah.
So A and B are settled. But C
A
and
and
D are
B is
to be enantiomers. Why will they not be enantiomers? Because the methyl carbon is fixed, right? This is in a fixed conformation. So let's call it R conformation. At this location where the bromine is present, I will get R and S. Yes or no?
yes. Yeah.
So will I be getting enantiomers or diastereomers?
Diastereomers. RS and RR.
So I'm going to be getting RS and RR there, which means I'll be getting diastereomers. That means one is off.
Mm-hmm.
Second case,
So
I will be
double
having
bond also form on the methyl also, no? Oh, sorry, my bad, nothing.
in the second compound there, I'm going to be having three possibilities: A, B, and an E in elimination. Right? Why
Yes, sir.
three aega? You get that there?
Yes, sir. The double
In
bond can
second
form on.
compound, we should be having A plus B plus E for the elimination, and C and D.
Yes, yeah. But only two should be formed.
And more critically, the C and D here are going to be again diastereomers, not enantiomers. Yes or no?
Yes, sir. Yeah. Mm-hmm.
So again out. Second compound is out. Third compound. Third compound, I will get A and B. That is fair. We already saw that fellow there. These two are the things here. This fellow and this fellow. This will
Yeah.
be A and B for the third compound. C and D, are they enantiomers is a question now. C and D will not be enantiomers. Why?
1 second.
They'll be diastereomers.
Yeah, these also RS, RR.
Right? RS and
RS, yeah.
RR.
Yes, sir.
So we have already eliminated out and got the answer as 4. Let's confirm it is 4. 4 may, what are my possibilities as 1, 2, 3, 4, 5, 6. Okay, so 6 carbon chain. So fourth compound answer is 4 now, obviously.
1 second. No, sir. It's C.
They'll
It's
give it
3.
C.
Yeah.
Nah, C is not correct. Wait. वहाँ पे CH3 OH आएगा. OH आ गया तो CH3 का chiral. And we have this fixed conformation only, that there is a different conformation. No, 3 is not correct. You should have diastereomers only obtained there, because the CH3 and hydrogen there, that is going to be chiral as of now. And is it chiral? No, it's not chiral. Yeah, it's not chiral. Because both sides are same. It's not chiral. Okay, that is where things change that. Okay, huh? Yeah, 4 is possible. I made a mistake here, and see, the third option is possible. I assume that that location is chiral. That is not chiral. That is here. If I get an OH and a CH3, in this particular case here, this carbon here, this location is not chiral. Why is it not chiral?
Sir,
Because this
which part?
side and this side are same.
Yes, sir. Yeah.
But the same problem comes over here. This is also not going to be chiral.
Exactly.
So I'm still conflicted over here. Let's go for the fourth option and check it out once. Then we'll come back to third. You're going to be having CH3 1, 2, 3, 4, 5, 6. Okay. I'm having one here. I have this one. Okay. Now if I do elimination on this, I will have one possibility like this. Okay. And the other possibility will be like this. So this can be A and B. Okay. If I do SN, I will be getting what here? This is not chiral at all then. This is not going to be chiral at all. Fourth is wrong, Doug. Fourth is wrong.
Hmm.
I think they have made a mistake in the question
Okay, sir.
because 3 is also not going to be. Wait, 3 may you'll get cistrons. But it is not chiral. It is not optically active. You get only cistrons. You will only get cistrons. None of them are correct, Ra.
Okay, sir.
None of them are correct here. C and D, in the case of third one, will not be enantiomers. That is over here. If you are looking at this compound, this is the compound which is C and D, correct?
Yeah.
If this compound has to be C and D, where do we get enantiomers? We won't be getting enantiomers. This is not
No.
optically active. You'll get cistrons here. That is this location, and this here you can get cistrons possibility, but it is not optically active. And same goes for Delhi. Delhi, if you, I mean, the fourth option. In the fourth option there, if I am plotting the last guy there, it will be this. This is not chiral. This carbon is not chiral. This carbon is also not chiral.
Correct. Yeah.
They are not going to be having any optical activity possible there,
Hmm.
which means there is no racemic mixture. And if you're not going to be getting enantiomers, that is not possible. And none of these are correct. And 1 and 2 will not give you, what to say, 1 and 2, what was the problem?
Diastereomers.
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 So that was also screwed. This is a wrong question, Ra. Sorry. I
Okay.
don't have an answer for you here. I'm getting it all 4 are wrong.
Okay.
You understood why all 4 are technically working out as wrong here?
Yes, sir. I will. Like each one has their.
There is no other option here. You can't really just look at the question and answer. We'll have to sit and plug the things here. There is no shortcut. I can give you
Okay.
another 10 minutes or so maximum. I'll have to get out in like 5-10 minutes.
Yes,
So,
sir.
do you have any more questions?
Sir, I had one more. Yeah.
Send it. You've sent?
Yes, sir.
Okay. 1,2 dichloroethane with this guy gives something and P. Okay. 1,2 dichloroethane. Okay. C4H8S2.
I don't think I've learned this. Nothing, sir.
Sorry, what did you say?
Nothing. Oh.
What happened?
I-
Okay. Another possibility would be this bugger goes and attacks here. And this guy leaves with he can get a polymerized shit. Weird polymerized one, but none of these weird ones they have given. None of these weird ones that they have given.
Hmm.
Trichloroethane ला ढूंढे कैसे आ सकता है? A is the current product, I think, right? A is the current product. What is the answer given?
One second. Yes, sir.
What the fuck?
She's never doing it.
That is what we got already. That is what we have. A is the answer given.
Yes, sir.
Then they are not. This is nonsense here. They should have put it as not plus P. They should have put this itself as P.
Yeah.
Then it is fine. Then
Okay.
it is fine. Then the answer is what we've drawn here. I can see that you're also about to draw it over there on the corner there.
Yeah.
So
That's
yeah,
right.
if A is the answer, then there's nothing there. There's a mistake. There's a printing error. It should have been given as C4H8S2. यहाँ पे P डालना पड़ेगा. And then they show us what is P. Instead of putting it as this plus P. The plus is the problem here. There's a mistake here.
Okay, sir.
I'm guessing this product is not a problem for you, no?
I know, sir.
So then straightforward. Okay, next one.
Sir, last one.
So you never even checked the answer for this question.
No, I didn't check it. I didn't even know what to do.
I understand. Sometimes you have to trust your gut feeling that things are wrong.
I was like, where did the other one even come from? I thought
It
something
does
random.
not make
Yeah.
sense. And none of the options given are making sense.
Yeah.
So, I'm guessing you also discounted the fact that option A is already the answer anyway.
Yeah.
Yes. Another one. Let's have a look. What are the products obtained from the following reaction? So we're going to be having a C minus, and we are having attack. Okay. And okay. In ether. In ether, they are hitting with a C minus. So the polar acrotic solvent. Ether is polar acrotic. So polar acrotic will favor which type of reaction?
SN2.
SN2. So you're going to be having SN2 being possible. Definitely. So we will not have option Delhi. We'll throw that out. C is a little too much over there because the C minus here is definitely going to be a very strong base. Much stronger. Let's go with how you get that C minus first. How do you get this C minus? If I want to get this compound, how do I get this? I have to take this guy and hit it with something like, say, NaNH2. Correct? Yes or no?
Yeah.
Will I
Yes.
get this with NaOH?
No, you won't. Because
That means this fellow cannot be removed by OH minus. Right?
yeah.
What
Yeah.
does that tell you?
1 second.
No reaction.
Yes.
That tells me that this ending is more basic
Basically, exactly. Yes.
than
Then OH.
any O minus.
Oh. Okay, fine.
Correct?
Yes, sir.
That means this is an extremely strong base. Can extremely
Yeah.
strong base do elimination?
No.
Yes. Extremely strong bases can certainly do elimination reactions. How does elimination happen? When you're going to be having, say, this guy, how do you perform the elimination reaction here? You do
The
ETOH and ETO minus, correct?
yes, sir.
What is ETO minus? A very strong base,
Strong base. Yes.
and this fellow is stronger than him.
Okay.
That's what we have just concluded, correct?
Yes, sir. Yeah.
So this fellow can absolutely perform elimination if the correct conditions are provided. Now, so option C, I will not go with. Option D, I will not go with. Let's look at A and B. A and B. We just have to decide which is 80% there. Which will
Hmm.
be 80%? A or B? Elimination has to happen, right?
Yes. Yeah.
So both elimination and SN will happen. SN products are both given as 20%. Now you have to only compare between A and B with respect to the elimination products there. Which elimination product is more stable?
The second one.
Why?
It's in conjugation with the.
Perfect. What's the answer
Yeah.
given?
B, sir. Yeah.
D or
B. Correct.
B? You understood how to work it out?
Yes, sir. Okay. Sir, but without knowing this before, we can't really solve it. No?
What do you mean by without knowing this before?
The
Without
fact that this thing is a stronger base than O minus.
which chapter are you supposed to understand that from? What did I give you here? What did I go with? What was
Hmm.
the reaction I went with? I took ethene and showed you these two reactions, correct?
Yes, sir.
Which chapter is that from?
Alkane.
Correct.
Okay.
So are you supposed to know this or not?
Oh, yeah.
You
Yes, sir.
understand why this is a fair question, right?
Yes, sir. Yeah, I got it. Yeah. Okay.
This is completely fair. This is a good question, actually.
Okay. Yeah.
You're supposed to realize that C minus in SP is actually automatically more basic than any O minus you will have, unless and until it is O minus 2. O minus 1 is definitely going to be a weaker base compared to that. If a normal alkoxide, ethoxide, can do elimination reaction in your normal E2, why would this not be able to do so? This should certainly be able to do it.
Yes, sir. Yeah.
You sent me one more
Yes.
question.
No, sir. That's it.
What a
Yeah.
random
That's
message.
it.
Okay. I think I will have to close the session, dude.
Yes,
I
sir. Yeah. That's it.
have
Yeah.
something else planned now. So
Yeah.
we will catch up again sometime this week. Mostly our
Okay.
regular Saturday thing. But
Okay.
you're going to be having holidays soon then, right?
Yeah. Next month.
Next month. That means after this week, you'll have holidays.
Yeah.
You're a North Indian? No, you're not North Indian. Right? But
No, sir.
Telugu fellow, you will celebrate Holi then. So happy Holi.
Yeah. Happy with this. Yeah.
Have fun. Yeah.
Thank you,
So
sir.
guessing one day your parents will happily but you don't live in a what to say society. You live separately, right? So do you have
There's
friends?
only not many, sir. No.
That will be
Yeah.
great. Where do you go play basketball and all?
Sir, my friends, it's like 20 minutes away, 15 minutes away.
So you actually have to go somewhere else and then play.
Yeah, there's nothing nearby.
Oh, okay. Huh.
Yeah.
Okay. Bye bye. Anything else to
Okay.
ask? Any other general
No, sir.
question to ask?
No, sir. That's it.
Have a nice day. Bye bye.
Have a nice day, sir. Thank you, sir.